Hello, my name is Lieven Penning. In this video, I am going to show you how to use the PDK libraries in the PlanOpSim software to make meta-surface designs using PDK libraries. The general workflow is outlined here in different steps. This is very similar to how any meta-surface is designed in the PlanOpSim software. You will start by selecting the component and the appropriate PDK library. Then you will go on to define the target wavefront, wavelengths, angles of incidence, and so on and so forth. Then the design will be run and any analysis to check if the design is what we intended are run. And then finally, the design can be sent to the manufacturing for testing or to have further information about how to manufacture. So let's move on into the PlanOpSim software itself. So I will change to my browser. And you see I'm here logged into my account and in the meta component module. I will start by making a new component that I call PDK. So I'll just call this PDK component and add it. And this now creates a new PDK meta component here. The first step I need to take after it loads is to set the size of the component and the library that I want to use. The most important part, and this is very similar to any meta surface design, is to select a library. In a standard design, I would choose, for instance, this library, titanium dioxide. If I want to use the PDK, all I have to do is go to the PDK itself here and select it. You will notice there's this lock icon next to it. That is because the structures are not editable because they are provided by the manufacturer. So I can select this here. This will give me this notification that I should check the description of the PDK itself. So we can check that here in the wiki, for instance. We'll go there quickly, where you will then find a description of the PDK itself. Here we go, with various details about which materials are used, which wavelengths are supported, and so on and so forth. So you can check all of that at your own speed, or you can check it later on in the wiki after you have done the design. But let's go back to the design itself, to our component, where we can check and select the meta surface PDK library. So I go to my component and I select the PDK, I confirm that I've read, and I use all structures. Voila. Actually, from this step forward, every part of the design is the same as in a standard meta surface design, as if you were using your own meta cell group. I'm now making a meta surface of 1 by 1 millimeter size using this PDK, which has been optimized for 940 nanometer wavelength. I can make different sizes as long as it is supported by the manufacturing process, which in this case is limited to 5 by 5 millimeters. So if I would try to set something bigger, like 6 millimeter, I will get a warning here that the PDK only allows a size of 5 by 5 millimeters. So let's set that back here to 1000 by 1000. And then I can go on to set my target design. So I move on to target and I make a new design target just as I would for any other meta surface design I'm doing. I have my target conditions, which are preset, and we can select them here. So this PDK was made for 940 nanometer wavelength, and we're using the set point for TE polarization. There's also one for TM polarization. And I set that here. And then I can go on and I define either the near field wavefront or the far field wavefront. I'm going to use the standard lens profile for this design, but you are entirely free to select any target. So I go into design wavefront. I pick the script that I like. In this case, I would like to use the aspheric lens script with a focal distance of 1000 microns for the wavelength of 940 nanometer. and I can click generate here. This will then create the wavefront target to be reproduced just like with any other meta surface design. This takes a little while to load because the software needs to calculate the wavefront based on the script that we have provided. So as I now wait a little bit to let that design finish, and when it's done, we will see the target pop up here below under amplitude and phase. So here we go. Here is both the amplitude and the phase of my target, and I'm now ready to start the design. So this is already step 3. So we go to design and we click start design. This starts the design process either on your computer or on the server where the elements are placed inside the structure. All right, after waiting for our design to finish, we now have the entire the design done. And you'll notice there's a new button here on the left called Request Fabrication. I will not click that now, but this is the button that will allow you to send your data through for a manufacturing quotation. So with my design, I can, just like with any other meta surface, first analyze its performance, for instance, going to the Analysis tab, and checking the focal spot or the near field wavefront profile. So let's start with the near field. I still have my wavelength of 940 nanometer here, and I can run this analysis here, confirm, and let the calculation do its work, and we will be able to inspect the near field amplitude and phase profile of the meta surface we just designed using the PDK. Voila, our design is done and we see the amplitude and phase profile. We can, for instance, check the cross section and see that it indeed produces the wavefront profile that we want. We can also check far field analysis. I will do that now by, instead of selecting near field, look at the far field. I'm interested in the focal position, so I set Z to 1000, the focal spot that I had mentioned before. And I'll reduce the inspection width a little bit here to 10 by 10 microns with a 100 step resolution. And I will start a new analysis, which will once again calculate. Okido, our analysis is done and we see here the spot profile and cross-section of the meta surface that we just designed. We see the typical airy pattern coming up. So let's assume I'm now satisfied with my analysis and my design. How can I now get this meta surface manufactured? We can go back to design and enter the new option that we saw before, which is requesting fabrication. So apart from the GDS, which in this case will not contain the actual structures, because this is manufacturer's proprietary data, but we can reach out to them for a fabrication request. So we go request fabrication. I select my number of pieces. So let's say I want 123 pieces, 1, 2, 3. And just to be sure, I will write this. If I now want to send this component for a manufacturing check, I can go to the request fabrication option, where I set my number of pieces that I'm interested in. So for instance, I'm interested in 321 pieces. As a comment, I will write that this is a test example. And then I have the option to either talk to an expert to get more information about the process, or to straight up ask for a quotation from the manufacturer. So I can click here, ask for quotation. This will notify me that my design and my data is now being sent to the manufacturer, so I can confirm this, and the software, once it's successfully sent, will confirm to me as well that this request has been submitted. I would like to point out as well that this PDK design feature is available to all users of PlanOpSim, and we are happy to answer any questions you have about PDK fabrication through our email address info@planopsim.com or any other way that you like. Thank you for your attention. Looking forward to your questions.